Hi, I'm Ian, and this is my performance task in Statistics and Probability, a video lesson about sampling distribution of sample means. So first, let's know the meaning of sampling distribution of the sample means. It is a table summarizing the outcomes and their sample means together with their corresponding probabilities. It is a frequency distribution using the means computed from all the possible random samples of a specific size taken from a population. So, how do we construct a sampling distribution of the sample means? Here are the steps on how to construct a sampling distribution of the sample means. First step is, we need to determine the total number of possible samples using the formula of combination, where capital N is the population size and small n is the sample size. Second, we will need to list all the possible samples. Next, compute for the mean of each sample. And last, construct the sampling distribution of the sample means. Here is the first example. A sample size of 2 is to be taken from a population consisting of numbers 1, 2, 3, 4, 5, and 6. Construct the sampling distribution of the sample mean. So the first thing we're going to do is to get the total number of the possible samples using the formula of combination. Here is the formula of combination. N factorial over n factorial times the quantity of n minus n factorial. Remember that the capital letter N is the population size and small letter n is the sample size. So if we substitute it, our population size is 6 and our sample size is 2. 6 factorial over 2 factorial times 6 minus 2 factorial. Now, since it's a factorial, we're just gonna have to multiply 6 to every number below it. We have 2 factorial down here, so we're gonna stop here at 2 and cancel it. So it will be 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1 is equals to 360 over 24. And when we simplify it, it's gonna be 15. So, there are 15 possible samples. So now, we're going to list all the possible samples, and based on the answer that we got earlier, there are 15 possible samples. So it should be 15, not 14 or 16. Otherwise, it's wrong. So here are the possible samples, 15 in total. And the next step is, we're going to compute the sample mean. We're just going to add the samples, then divide it by 2. We will divide it by 2 because 2 is the sample size. So first is 1 plus 2 divided by 2 is 1.5. 1 plus 3 is 4, then divide it by 2, so equals to 2. And then just repeat the same process to other samples to get the sample mean. Add them, then divide by 2. Here are all the mean of each samples. And the last step is to construct a sampling distribution. So here in the sample mean, we don't need to put the same mean. All we need to do is just arrange them from lowest to highest, then count their frequency, and it should look like this. So for the probability, we put 1 over 15, 2 over 15, and 3 over 15 based on their frequencies. And it's over 15 because there are 15 sample mean. If you add all the frequencies, they should be equal to 15. Same with the probability. It should be 15 over 15 or 1. Now, I have another example, but this time, you try to answer it on your own, then I will show the answer later. There are there are 5 newly hired nurses at Tondo Medical Center. The number of COVID-19 patients treated by each newly hired nurse last month was 3, 4, 5, 6, and 7. If 3 nurses will be selected at random, construct a sampling distribution of the sample means. You can pause the video in each step and play it again when you think you're done. So the first step is to compute the total number of possible samples using the combination formula. You can pause the video. It should look like this. Cancel both 3. 5 times 4 is 20 and 2 times 1 is 2. So 20 over 2. And when we simplify it, it's gonna be 10. So there are 10 possible samples. Next step is to list the 10 possible samples, and it should look like this. And then the third step, we will compute the mean of each sample. We will add them, then divide it by 3. The result will be like this. For the last step, we will arrange them from lowest to highest, count their frequencies, and total them. It should look like this, equal to 1. And here are the importance of sampling distribution of the sample means. That's all. Thank you.